All right, we are on to 3.5 factoring. So it's kind of a long process, might take a little bit to get going, but once you get the hang of it, hopefully it'll start to fly by. So example one, if you remember, well, hopefully you remember from Algebra 1, we could multiply two polynomials using a box. And so we would take our first binomial, we would put x and 3 on the top to represent x plus 3, and then we would put x plus 5 on the side, and then we would multiply. So we would start with x times x, and we'd get x squared. Then we would go x times 3, we'd get 3x. Then we take x times 5, and we would get 5x, and 5 times 3 is 15. So if we were to write it out, then we would have x squared plus 3x plus 5x plus 15, starting with the first box, second box, third box, and fourth box. Then we have some like terms we could combine. So our final answer would be x squared plus 8x plus 15. So we could multiply using a box. We can also factor using a box, which is just reverse multiplication. So we started with two binomials, ended with a trinomial. Now we're going to go in reverse. We're going to start with a trinomial, work back to a binomial. We're going to use the box to stay consistent here. Now here's a setup. So we're going to take our first term, our a term, put it in the first box. Our last term, 15, goes in the last box. Now the problem is we have one number left and two boxes to fill. So here's what we're going to do. We're going to start by taking a times c, so 1, so 1 there, times 15 is 15. Then we're going to look for one factor pair whose sum, when you add them together, you get 8. So if you don't know, you could just list all the factor pairs of 15 out. So 1 times 15, 3 times 5, and that's it. So you're looking at these factor pairs and you're saying, okay, 1 plus 15, that's not 8, so it can't be that one. Then you take 3 plus 5, we get 8. So hey, that's the factor pair, 3 and 5. So then what you do is you put 3 and 5 in those boxes, and then whatever this variable is, they follow. So there's your setup for factoring. The biggest thing is taking a times c and finding the correct factor pair. It's probably the hardest part. The rest of this is just greatest common factor. So then what we want to do is we want to figure out, what are we putting on the outside of this box like we had over here? What's going to be on the outside to give us our two binomials? In order to figure that out, what we're going to do is look for the greatest common factor. So we'll start with the top row. X squared and 3x, what do they have in common? Hopefully you could tell me that they both have an x. So we're going to take an x out. And we'll go to the bottom row. 5x and 15, what do they have in common? That would be a 5. Okay, going up the left column. X squared and 5x, they both have an x in common. Oops. They both have an x in common. And then up the right column, 3x and 15, they both have a 3 in common. And if you're not sure if you did it right, just go back and multiply. X times x is x squared. X times 3 is 3x. 5 times x is 5x. 5 times 3 is 15. So if you get all the numbers back when you multiply, then you know you factored correctly. So the last thing then is just to write your answer. So from the top, we get x plus 3 because it's a positive 3. From the left side there, we get x plus 5 because it's a positive 5. And so that's factoring. And the nice thing about the box method is it works no matter what the a value is. If it's 1, 2, 3, 4, 5, 100, it doesn't matter. It all works the same. Now, I can also show you a shorter method for only when our a value is 1. So I'm going to go ahead and do that here in example number 2. It says factor x squared minus 10x plus 9. Worst case scenario, you go back up, you use the box, you factor how we did that example. If you want to use the shortcut again, that's only when my a value is 1. Here's how you'd set it up. So you'd set up your 2 parentheses. Okay, because what we want is 2 binomials like we had up here. Okay, your variable is x, so we're going to have x in the first parenthesis, x in the second parenthesis. Okay, then we're going to take a times c again, so 1 times 9 is 9. So factors of 9 that add up to negative 10. So you're probably thinking, okay, 1 times 10, or not 1 times 10, goodness, how about 1 times 9? And 3 times 3. So if I add 1 plus 9, I get positive 10. Well, that's not what I want, so it can't be that one. 3 plus 3 is 6. It's not what I want, so it can't be that one. And you're probably thinking to yourself, I'm out of solutions. I don't have any more factor pairs. But on this one, you got to think outside the box a little bit. How about this? How about negative 1 times negative 9? If I multiply, I get positive 9. So that's a factor pair. You could also say the same thing. Negative 3 times negative 3 also gives us positive 9. Okay, so now we have 2 more that we can work with. How about negative 1 plus negative 9? Does that equal negative 10? Hopefully you can tell me yes, it does. So then you take negative 1, we'll put it here. Negative 9, we'll put it here, and it's factored. Now again, that's a shortcut only when a is 1. If you put negative 9 in the first parenthesis, if you just flip the negative 1 and the negative 9, order doesn't matter in this case. You'll notice here in the box method again, so we've got 3 and 5. Look at these 2 values, positive 3, positive 5. Again, that only works when a is 1. So let's factor this one using the shortcut again. Because my a value is 1, I can go ahead and do that. So here's my 2 parentheses. We'll go x and x. If you take a times c, we get 8. And this is the hard part. This is the part you're going to have to do no matter what method you use, the a times c part. So we're looking for factors of 8. So 1 times 8, 2 times 4. And technically negative 1, negative 8, negative 2, negative 4. You don't have to list them all out. As soon as you find the right one, use it. So 1 plus 8 is 9. We're trying to get to 6. Can't be that one. 2 plus 4 is 6. We're trying to get to 6, so we're good. So then we're going to go plus 2 for that, plus 4 for that. And that's the shortcut. Okay, save you a little bit of time. Factoring patterns, we'll skip that. Something hopefully we can take a look at in class. So factoring again. X squared minus 8x minus 20. So because my a value is 1, we can use the shortcut here. I'll start with my a times c. A times c is negative 20. So make sure you get that sign correctly. If it's positive 20, that's going to make a difference. Negative 20 makes a difference. So we're going to set up our parentheses now. We'll go x, and we'll list the factors of negative 20. I'm just going to list them all. If you know what the correct one is right away, use it. So negative 1 times 20 is negative 20, and then you can just flip the sign. Negative 2 times 10, and you can flip the sign. So when your a times c is a negative number here, you're going to end up with more factor pairs than you probably care to use. But until you get used to finding the right one, until that starts to click, the best way is just to list them all out. So let's see, we could also say negative 4 times 5, and flip the sign, and that is it. So starting from the top, let's add them all up. Our goal is to get to negative 8 now. So negative 1 plus 20 is 19, not going to work. 1 plus negative 20 is negative 19, so that's not going to work. Negative 2 plus 10 is positive 8. Close. We're trying to get to negative 8, so we know that that's not it, but it's probably those numbers, just the signs flipped. And if you check 2 plus negative 10 is indeed negative 8. So we got the negative 8. And again, because a is 1, you can just go plus 2 minus 10 from that special factor pair that you found. Nice little shortcut for you. Okay, again, similar example. We'll set it up, and we'll go ahead and take a times c. A times c is 50. Okay, our goal is to end up at negative 15. When we add these two factor pairs together, we have to get to negative 15. So if you're thinking to yourself about this one, it wouldn't make any sense to have two positive numbers. For example, 1 times 50 is 51. I need a negative 15. You could say the same thing about 2 times 25. I'm going to get positive 27. And whatever two positive numbers you use, it's not going to work. Which means I might have to use this trick again, where I have maybe two negative numbers. If you want, go ahead, continue to list them out. I will. 3 doesn't work. 4, 5 times 10. Again, if you add them together, you get positive 15. Not what we're looking for. We want negative 15. And then, so, okay, you're thinking, well, how about negative 5 times negative 10? Will that work? Yes. Negative 5 plus negative 10 is negative 15. So if you can list the factor pairs, then all you have to do is be able to add, and you will be good to go. Otherwise, I mean, this right here, this is the hardest step, and it's going to be there whether you use the box method or if a is 1, you use the shortcut method. So just some different things to think about here. I'm going to skip the next two. Let's do some factoring when a is not 1. So with these examples, I would definitely use the box method. There's other methods. Guess and check is one, and that can kind of be a pain in the butt. As the name suggests, it's literally just guessing using a little bit of number sense, and you just have to keep checking, keep multiplying it out to see if it works. So I'm going to use the box, though. It may take just a little bit longer, but it's going to work every time, which is nice. So here's my setup. My first term goes in the first box, 2x squared. My last term goes in the last box. And I do this first. And then I'm going to go ahead and off to the side take a times c, and we get negative 12. Okay, so I fill in the first two numbers, and then we're going to fill in the other two by taking a times c. So factors of negative 12, you could say negative 1 and 12. And let's see our goal here, just so you know. So we'll see if we get it before having to list them all. Negative 1 plus 12 is positive 11, so I'm really close. I just want negative 11. So that means if I flip the signs, it's probably going to work. 1 plus negative 12 is, negative 11. So there we go. We have our answer. Or not our answer, but we have the two numbers we're looking for. So we're going to go 1x, negative 12x. Again, order does not matter there. You could have put the negative 12 in the top right box and 1 in the bottom left. It doesn't matter. Now we're going back to GCF, greatest common factor. So along the top row, 2x squared and 1x. The only thing they have in common that you could divide out is an x. Let's go like this first. All they have in common is x. Along the bottom row, the only thing that they have in common is they're both divisible by negative 6. Going up the left column, those are both divisible by 2, and they both have an x in common. So now we have a number and a variable that we can divide out. And now here, don't overthink this. 1x and negative 6, the only thing that they have in common, the only thing that you can divide them both by is 1. And sometimes that's all you're going to get. So the final factored version, from the top of our box, we have 2x plus 1. From the left side of our box, we have x minus 6, and it's factored. Again, maybe feels like a long process, but I promise you, unless you're really good with your number sense, it's better than guessing and checking. So we'll do one more here. So set up our box. Okay, we're looking for those four things. A, B, C. So my first term, 2x squared, goes in the first box. My last term goes in the last box. And then take A times C. A times C is 12 again. Okay, this time our goal is to get to positive 7. So, if you know it right away, jump right to that. You don't need to list them all. I'm going to start with 1 times 12. If I add them up, I get 13. Not that one. 2 times 6. If I add them up, I get 8, so I'm getting closer, but that's still not 7. 3 times 4. If I add them up, I get, oh, there we go. I get 7. So, in the other two boxes, we'll put 3x and 4x. And then we're just going to find the GCF again, starting with the top row. 2x squared and 3x, they're both divisible by x. They both have an x in common. The bottom row, 4x and 6, are both divisible by 2. That's the biggest number they're divisible by, I should say. That's the greatest common factor, the biggest number that these problems are divisible by. Up the left column, 2x squared and 4x. They're both divisible by 2, and they both have an x in common. And then going up the right column, those are both divisible by 3. And again, if you multiply it back out, we should get everything in the box, which we will. So our final answer, starting from the top of the box, we get 2x plus 3 because it's a positive 3. And from the left side, we have x plus 2. And there you go. Factored form. We got two binomials. The only other thing that I could add is finding the greatest common factor first. So if you look at a problem like this one right here, and you're thinking, okay, this looks a little bit different. Normally when I factor, I have at least one term without an x here. I'm looking at this one. I see an x with all of them. Well, right there, that should tell you there's a greatest common factor. I can divide all of these by something. I can take something out of all three terms. If you can do that first, always do that. So starting with the obvious one, they all have one x in common, so we'll take an x out. And also, if you notice 4, -2, -6, they're all divisible by 2. So if I take a 2 out as well, what that's going to leave me with is 2x. And then if I actually divide here, so 4 times 2 is 2. I had 3 x's. I'm taking 1 out, so now I have 2. Okay, right here, -2, well, -2 divided by 2 is -1. I had 2 x's up top, but I'm taking 1 out, so now I'm left with 1. If you want to clean that up, go ahead. We don't need to write the -1 in there. We'll just go -x. And last but not least, -6 divided by 2 is -3. I had 1 x up here, but I'm taking 1 out, so that's it. So you factor out the GCF, and then you're left with this right here, which you can factor because A is not 1. You probably have to use the box, just like we did up here. And then you'll get a final answer. It's going to look something like this. So when we factor that highlighted portion, we'll get a binomial. 2x and x. I'm just going to try to get this factored out here really quickly. I think it'll be -3 plus 1. So 2x squared minus 3x plus 2. Yeah. And then don't forget to take the 2x and to put it back on the outside. So we have what we normally would have right here. But then the GCF also has to be a part of our answer, the 2x. And that would be it. So there's a couple more there if you want to take a look at those. And then here's one last one with the greatest common factor first, and then factor. In this case, again, you'll have to use the box. So just some things to look at. Factoring can be a long process. Unfortunately, it's one of those things it's not going to go away. It'll be around for a while. So make sure we take some time and look at this and ask questions if we need.